Hi everyone, this is going to be the last video for today. We are going to finally learn how to add vectors quantitatively using the idea of components that we studied in the previous video. So let's start with a basic example when vectors are parallel and we are trying to add them. So one way to think about it is if your car is stuck here and you're trying to push it from behind and your friend asks for help, which direction would they push or pull in, right? Whether they're gonna pull, which would be in this direction, or they're gonna push. Like obviously, if they push, then that's not really gonna help because that cancels out what you're doing. But if they pull, it adds up, right? What does that mean? If I add two parallel vectors, then I get a vector in the same direction but longer. Similarly, if I add two vertical vectors, what I get is a third vector in the same direction that is vertical but just longer. So these are easy cases, which means that theoretically speaking, if I want to add two weird vectors together, right, I can use something called components, because I can say that, well, this vector is really just a horizontal and a vertical vector, and this vector is really just another horizontal and another vertical vector. So I know how to add these parallel ones, and they give me something longer, and I know how to add the vertical ones, and they give me something really longer. And the next step, I know how to add them. If I have a horizontal and a vertical, I know I can place them together, draw a parallelogram, and get the sum. So pictorially, that's the idea. We take what is easy, we break the complicated stuff into the easy things, and then we just add them with the easy things and then recombine at the end. So let's look at a general situation. Okay, let's say here's my vector A and here's my vector B. And I'm given that magnitude of A is 10, the direction of A is 60 degrees, the magnitude of B is, say, 5, and the direction of B is 20 degrees. So my first goal is going to be break into components. AX is going to be 10 cosine 60. AY is going to be 10 sine 60. See if I can, okay, here's my calculator. It's going to be 10 cosine 60 is 5. 10 sine 60 is 8.66. Do the same with vector B. So Bx is 5 cosine 20. By is 5 sine 20. 5 cosine 20 is 4.70, and 5 sine 20 is 1.71. So right now in this picture we are here. We found AX, AY, BX, BY. And now we're going to do this addition. That's horizontal, so I can just add them together. 5 plus 4.70, 9.70. And AY plus BY is 8.66 plus 1.71, 1.71 plus 8.66, 10.37. So we have these vectors now, yeah? This vector is the 9.7, or the length, and this is 10.37. Now the last step is the recombining vectors. Okay, so recombining vectors. So what we have is, we have a horizontal one which has a length of 9.70. We have a vertical one that has a length of 10.37. Now by addition, we know that that's the recombined vector. Right? Let's call this vector R. Okay. R, the recombined or the resultant vector, is the sum vector. Now, if this is 10.37, this is also 10.37, and this is a right triangle. So by Pythagoras theorem, the magnitude or the length of this arrow is going to be the square root of 9.70 squared, 10.37 squared. What does that give me? Square root 9.7 squared plus 10.37 squared is 14.2. So that's the length. Now what about this angle? Let's call this the angle of R. Again, using trigonometry, I know that tangent of theta R is opposite over adjacent. So 10.37 over 9.70. So this is tan inverse of 10.37 divided by 9.70. So that's going to be tan inverse 10.37 divided by 9.70, 46.91. 46.91 degrees. So if I go back here, I had vectors A and B. When you add them in this diagram, you get this parallelogram. That's vector R. What's the length of R? It's 14.2. And what's the angle? It's 46.91 degrees. That's the angle and that's the length. So that's how we can find the sum of the vectors, also called the resultant vector. And in the next video, I will generalize these formulas. But just notice that what are these numbers? These numbers are essentially AX and AY, right? AY and AX. So you can find a general formula for finding the magnitude of R and direction, but really what you're using is Pythagoras theorem and trig ratio, specifically tangent. So you don't really have to remember it if you just make the triangle. Okay, that's it for this video.